This is a demo of the APQ TLS implementation using their dummy cryptography before putting in the real cryptography. In short, we got two pieces to this in order to make it work. We got the protocol gateway, which would be running on the Azure side. In terms of testing and development, it runs locally, and the code for actually doing the handshaking as well as doing the encryption both ways is the DCM provisioner. It sits in channel with everything else along with the TLS stack and TCP/IP and everything else, takes care of the messages it's supposed to do, and then passes them back and forth as necessary. And it gets loaded here instead of TLS, standard TLS using AES and certificates and such. Just gets loaded here in the channel pipeline on the gateway. Over on the client side, we have the standard UMQTT client, which is published by us in open source. And the only changes here, there's some data that's in here that tells it to pass through connect to Azure IoT Hub. And inside the Azure IoT Shared Util, there's some additional source files, one of which is this TLSI DCM.c file. And that's the thing that handles the client side of things. In other words, it tells the layers above it's running TLS. It takes care of the below the covers handshaking and cryptography as it goes back and forth. And again, this is a simple dummy example, which they're dropping their library into. So it does nothing more than a simple two's complement type of encryption. If we run this, we're going to start with the protocol gateway. So we'll get the gateway running here. It'll pop up and loads the channel handlers and everything else that needs to run. Everything's good. So we're going to minimize that for right now. And then we're also going to then run the client. Now the client is already pre-built, so I'm just going to run it as an executable. And over here, I'm going to start Wireshark so we can actually see what's going on. And I also have running the Device Explorer for Azure IoT. So if we run the client, it will connect into the protocol gateway. And if we look at the protocol gateway's information, we can see that it's actually sent a handshake, sent an echo, and as it's going, it's showing both the encrypted and the decrypted data that goes back and forth. On the client side, there's some additional keys in here where we can press S to send a message, but before we do that, let's go take a look at that. So we're monitoring the messages on the client side. If I press S, we're sending a pre-packaged message. And likewise, if we want to send a message to the device, we have a test we can send here. You can send to IoT Hub, and then of course relayed through the protocol gateway down to here. You can't really see a whole lot in here except for the initial handshake. And part of that is, of course, that it thinks it's encrypted. It just sees the two's complement. So we see a typical TCP SYN/ACK. Then we see some handshaking that goes on here. It thinks it's secure sockets just because of the port. But then after that, it creates, again, a handshake and starts sending data back and forth. That's pretty much it. Now the next step, of course, is to simply drop their crypto in there and then get their protocol gateway version into the Azure marketplace.